So we'll start off first just by having a look at channel 1. So we'll at the moment it's on 10 volts per division, and I can see that there is a bit of something there, so that's okay. So turn it on to 5 volts per division, yeah, that's looking a bit bigger. 2 volts, 1 volt, and that matches now our 1 volt peak to peak, so that's approximately right there. Okay, 0.5 volts peak to peak, so that should be about 2 divisions, which it is, which is fine. 0.2 should be 5 divisions, which it is. Going off screen there, but it looks to be working off screen there on 50 millivolts, 20 millivolts, 10 millivolts. Yeah, so channel 1 is working. So this is now our channel 2, which is the one that's got the problems. So the 10 volt range seems to work okay. I can see there's a bit of a sine wave there. So we're on channel 2 now, and still 1 volt per division, and there is I can see there is a bit of a waveform there, so that looks like it's working. 0.5, yeah, that's probably okay as well based on our 1 volt. But when we go to the 2 volt per division there, where we should be seeing something, the waveform has pretty much disappeared. The 1 volt setting, that should occupy now 1 full square, and it doesn't. The 0.5 should be bigger still, and it isn't. And then we go to the 0.2 volts, and that's working again. So basically some of the settings on this switch don't work, and we need to find out why. Okay, I think the explanation I was trying to give before was really a bit rubbish. You know, sometimes you're trying to talk and think at the same time, it doesn't really work, does it? So we've reset the signal generator, and it's now outputting 5 volts peak to peak, and the channel 2 is set to 10 volts per division now, so we'd expect it to be about half a division, and it's a bit more than that, but it's all a bit fuzzy, and yeah, that might not be bad. If we put it to 5 volts, that's okay as well. It's interesting to see that there appears to be a lot more noise on there, and I think that'll be 50 Hertz noise. But I'm not worrying too much about that at this stage, because I'm just wondering if it's more of a screening issue than anything. Because I notice if I put my hand near the scope, you can see that I'm actually coupling noise into it. So yeah, there could be a problem there, but it might not be a problem. It might just be more of a fact that it's just all a very high input impedance circuit. So we might come back and have a look at that. But the 10 volt range and the 5 volt range are working, so that should be about a division now, and it probably is a little about a division if we put the noise onto it. But if we put it to the 2 volts range now, this should be twice as big, and it isn't. And if I go to the 1 volt range, it should be bigger again, which it is a little bit, but I'd expect this to be 5 divisions high now, and it's not. And now finally, if I go to the 0.5, again we'd expect it to be pretty much off scale now, and it's not. If we go to 0.2, it works normally. So there's something wrong with the 0.5, there's something wrong with the 1, and there's something wrong with the 2. But the 5 and the 10 is fine. So I think what we need to do is have a look at the switching circuit now and the makeup of the vertical attenuator section to find out to find out, is there anything common to the 2, 1 and 0.5 volt inputs which would explain why we're getting a problem. Well, I'm hoping you'll be able to see this, but if not, I'll blow it up on the computer later, and so you can actually see it. So basically you can see here these are the selector switches here which set the attenuation, and it's a little bit strange, or I think it's a little bit strange the way they've chosen to put this in the manual, that they've got a section which they've got that divides by 1,000. They've got another one which they call divide by 100, divide by 10, and then divide by 1. And I do think that's a little bit of a strange way of putting it, because you know, you would have thought, for me it would have been more useful if they'd actually wrote what the switch settings were on the front panel. So the divide by 1000 here is going to is represented by the I've got to check now, the 5 and 10 volt settings. So just for my benefit, I'm going to write that on. So 10 volts, 5 volts, and they work okay. So what the next one was, 2 volts, 2 volts, then we had 1 volt, then we had 0.5, 0.5 volt. Now they were the those were the three that were giving us problems there, and I think that's quite telling. I could be wrong, but I think that's really strongly pointing towards something with this. This is the divide by 100 section, but let's just keep going right in the voltage on these switches. So we had 0.5, and then we've got 0.2 here, 0.2, and we had 0.1, 0.1, 50 millivolts, and then turn it again, just having to look around the camera, 20 millivolts, and then I'm guessing it was 10 millivolts. And what was the final one? Final one on here is 5 millivolts per division. Okay, let's just have a look at the actual attenuator circuits now. So it's actually got it just split out in the manual here. So there's the divide by 1, which is used for the 5 millivolts and 10 millivolts per division range. Then we've got the divide by 10, which is used for the 50 millivolts, 0.1 and 0.2 volts. And now we've got our suspect one, which is the divide by 100, which is being used on our 0.5, 1 and 2 volt. And that's the one that's giving us jip at the moment, that doesn't appear to be working properly. And then finally we've got our divide by 1000 range, which is for the 5 and the 10 volts. That's our divide by 1000 there. So the most obvious thing to me would be to look at this divide by 100 network here. And what I'll do is, I think I'm just going to check all of these, well, these two resistors. I just can't read them on my circuit diagram at the moment. The is that R? I don't know, that looks like R004. R004 and R005. So I think the first thing to do is to check the resistance of those. It says it should be looks like 990k and I don't know, is that 10.1k? I don't know, hard to read at the moment. I'll have a closer look at them in a minute. So we're going to check them voltage levels, and also check that we've got the ground connection on the negative side of the voltage divider. I suspect we will have the negative side, because otherwise the voltages would have read high rather than low. The other things that we perhaps want to check for is things like short circuits in this capacitor here. What's that? C008, or maybe a short circuit in this variable trimmer capacitor, this C007. Any of those could pull the input voltage down and make it not work properly. So I think it's worth checking that bit of the circuit out first. I'm taking me. I say I'm struggling to read them. I've just got some new glasses, and the varifocals, and I've never had varifocal glasses before, and I thought they would be better for, you know, electronics work where you're looking at distance and looking down and stuff. And yeah, I don't know. Verdict's still out. Kind of. I feel like I'm in a bubble. Feel a bit sick whenever I'm wearing them, and. Yeah, I'm still having to take them off and put them on again, which is the problem with what my old glasses were. God, it isn't getting old, a bugger. It really is. Either that or my gram was right. I really did go blind. Yeah, I'll have to stop doing that, won't I? And we'll just see if the values of the resistors are anything like what it says on the data sheet. So the first one we're going to check is, we'll check this. think it's 900 ohm, sorry, wrong one, 990k resistor. So we'll check channel 1 and we'll also check it against, we'll check channel 1 resistor and we'll also check channel 2. Remember, it's channel 2 that's got the fault. So where is it? There it is. Channel 1. Alright, 988k, near enough. Let's check the other one, channel 2, 985, again close enough, certainly not open circuit. So that one was okay. Let's check the negative side of the divider. What value should that be? Just struggling to read that. That's 10.1k. So check channel 1 again first. Yep, 10.1. Channel 2. 10.1 again. So that's close enough. So both those them resistors in our attenuator chain seem okay. Let's just see if we can find these capacitors which are in that could pull it down to ground, could pull our signal down. Where are they? They are 107 and 108. Let's see if we can find them. They are a bit hard to see, some of these. There's 108. Yeah, which is reading 10k. Which would we expect that? 108. Well, it's the same as yes, we would, because it's across. Yeah, so C008 is in parallel with the 10k one, so we're going to see 10k, aren't we, because it's going to be open circuit capacitor. So can we find C007? Can we find that? That's a variable capacitor, isn't it? I'm going to go for that one there. I don't know if it is that one, but that's the one I'm going to gun for. That one's reading just under 1 meg. I'll just check channel 1 for comparison, which is also reading just under 1 meg. Just got another capacitor here, which I'm just checking, it's just the adjacent one. Again, effectively open circuit. So yeah, it's not the capacitor shorting it out. So yeah, I was really expecting that to be the problem. It doesn't mean there isn't a problem with this attenuator switch, because there, you know, it could still be a problem with the switch, because obviously we have to switch through this. We have to switch through this circuit, don't we? So it could be that either the wiper on this side of the circuit is open, or the wiper connection on that side is open. So it could be that. I'm wondering if maybe the next thing to do though is actually do some signal tracing. Yeah, maybe that would be the correct thing to do. It's not like we're short of oscilloscopes, is it? Let's do some signal tracing. That's going to be good for a laugh. And again, the great things about oscilloscopes is we've got, because we've got channel 1 and channel 2, we have got a good channel to do our comparison again. So yeah, let's do that. Let's see if we can trace the the signal through from the input and see where it appears to be going astray. Right, so we've got both the scope inputs connected together, and we've got both the attenuator switches for channel 1 and channel 2. They're both set to the same thing, which is 2 volts per division. I'm just going to check we have actually got a signal coming in to start with, which we do appear to. Okay, so we've got a signal coming in. So we need to find the output of these attenuator circuits, and it looks as though the outputs are being developed across, for channel 1 it's being developed across R008, and then the way that the circuit diagram works, they've got the other channel 2 printed next to it. So the resistor for channel 2 is R108. So let's look at 008 first. We've got to find it first, haven't we? Come on, somebody tell me where it is. Well, sometime considerably later, as they say. Still haven't found that resistor, but I found one near enough. Right, so what I'm looking for is, we've got, just to recap for my own benefit, we've got 5 volts going in. We've got a divide by 100 stage, so the output of that we should be expecting 50 millivolts. So let's have a look at channel 1 first, which I think will be there. And we have got that on 50 millivolts per division, and it's 1 division. Let's just see, increase the... Can we get 5 divisions? Right, we're on 10 millivolts per division now, so we should be expecting 5 divisions on here. 1, 2, 3, 4, 5. Yeah, just over. Got a little bit of noise floating on it, but it's quite a small signal. So, okay, all so far so good for channel 1. Let's look at the same point on channel 2 now. We've got nothing there. So there's a bombshell. Go back and check the other one. So we've definitely got nothing coming out of our voltage divider stage. Yeah, we're not getting a signal there. That can't be right. Oh, bugger. I know what's wrong. I know what's wrong. Yeah, the eBay seller, when he sold this scope, he didn't mislead me at all. I'm just thinking of exactly what he said when he posted. What he said was the channel 2. I think he did say the channel 2 input switch was broken. I think he said that. I could be wrong. And you know what I thought he meant? I thought that he meant that the switch didn't work. But I'm looking at it now. I don't know if I can bring you in. Let's see. There's your problem there. The chap wasn't lying to me, was he? I think he said the switch was broken, and I should have took him at his word, shouldn't I? Because the PCB board that the switch, is made up of, is broken in half there, and that one is also broken in half. I can see a crack running clean through the traces, and I'm trying to work out if the switch looks pushed back. I don't think it does look pushed back, but yeah, there's the problem. It just seems funny that we've had again 2 of these scopes, and we've had very similar problems in that it was these switches that were broken on both of them. I mean, one of them, it was the fingers on the switch contacts that were broken, and on this one it was a physical PCB. It's a physical PCB board that's cracked on it. But I guess, you know, maybe there's a, you know, kind of typical faults that scopes suffer, and I guess if there is some mechanical movement allowed in the actual switch itself, that's going to transfer through. It's a shame though, this scope's in really good condition, so it's, you know, it is a shame that it's got a broken switch wafer. Oh, old friend Mr. Electric Screwdriver there. I think I should have an adjustable spanner here somewhere. There it is. I did think I'd make a video one day. I think I might even just do a video going through all these drawers, because I always like to see what is in other people's toolboxes and what people's favourite tools are. I always find that really interesting. So maybe some of you people will find it interesting to see what's in my drawers. Came undone easily. No, came undone easily as well. It is Mr. Electric Screwdriver time. Everything unplugged, haven't we? Yeah. I do like these. It's got little quick connectors on it. See if I can bring you in. These wires here, which are, you know, the Y controls. They go to the straight to the deflector plates on the Y on the cathode ray tube. But you kind of pull them and it releases a single core wire, and you put it in. Not single. It's a multi-core wire that's been tinned. You just press it shut and it grabs the wire, and you pull it and it releases. It's kind of, yeah, kind of like that. I wonder why they didn't put like a more of a single pole header on it. This must be a bit more positive. Sorry if I keep bumping the tripod. It's quite awkward. You know, wherever you seem to put the tripod, it's, you either can't see what I'm doing, or you know, the tripod's in my way, and it can be quite difficult working around it. But yeah, we'll do our best. Right, we need a screwdriver now. Well, let's use the electric one, if it will go in. Right, I think we're all disconnected. We'll soon find out. It'll come out. There we go. And I should be able to show you those broken switches a bit better now. Hopefully you can see that. Can you see where I'm poking my finger there? The circuit board is cracked right across. Maybe I can get you in. It's just difficult to try and get the camera in. So this one is cracked here. Can you see the crack? I'm trying to work out. Right, okay, I think you can see that. You see it's cracked, and it's actually cracked all the way across. It's cracked straight through to that side. And it's not just that the circuit board is cracked, there's actually traces running up there, and all those traces have broken. This one is similarly got a crack in it, and again it's broken all the tracks. That side is cracked and it's broken all the tracks. So I'm hoping you can see that. This board here doesn't look to be cracked. That one, come on, focus again. You know what I'm going to do, guys? I'm going to take that other board out from the original scope and maybe look at this as a more long-term fix thing, because it'd be nice to have one scope completely working as opposed to two scopes that are a bit kind of iffy. Yeah, I've just been sat here pondering. I think we'll take the other. It's an older board. I think we'll take the older board that I replaced the the trigger preamp on previously on the other video. I think we'll take that vertical board out, and I think we'll replace this one with that. I mean, effectively it means that rather than having two kind of working scopes, I'm going to have one scope which is, you know, kind of perfect, as opposed to two scopes that have kind of got bodgy repairs on them. But I think maybe that'll be a more sensible approach. And there's nothing to stop us, you know, having another go at this at some other time. There's just such a lot of damage on this switch. If I didn't have a spare available, I would definitely have a go at repairing it, because I think you probably could patch it up, and if you were gentle with it, it probably would stay repaired. But there is quite a lot of force. I suspect when you do turn the knob and stuff, I bet there is quite a bit of force transferred through. And yeah, it's cracked wide open, that. Maybe you can see that better with it actually upside down. Yeah, it's cracked wide open, isn't it? Yeah, we'll do that, guys. Sorry, I just wasted your time there waffling, but to be honest, I quite like having a conversation with you, even if you don't always talk back. Well, you do talk back. You leave your comments, and I will say now how much I enjoy people that leave the comments. Everybody leaves a comment. It's got Joe and Radio Cruncher and Simon and Vintage Electronics. And sorry if I've forgotten anybody there. Oh, and Andrew from his Pie channel. All you guys take your time to post lovely comments, and you're always helpful. And I think that's the thing that I'm really enjoying most about this little YouTube channel that I've set up. It's not just the repairs, it's the fact that, you know, I never thought I would make friends like I have done. Because, you know, if you're kind of a geek like I am, you don't get to talk electronics every day. I mean, I can try and talk electronics to the people at work and they just roll their eyes and they're not very interested. But this opportunity to, you know, talk electronics and swap stories, I'm really enjoying it. So thanks very much for all your comments that you leave. It's really good. So just to recap, we've got the vertical board from the old oscilloscope, the one that had the defective horizontal time-based control that we repaired previously. And also this is the board that's in here now, the one that had the problem with the trigger, and we replaced the preamplifier for the trigger preamplifier that we replaced. I wonder if it'll make any difference having a mixture of, you know, the older and the newer circuit boards in here, because again, the one on the right is the horizontal control is from the new scope, is the board that came with this scope, and the vertical is another board. So I'm kind of thinking that perhaps it would be worth going through the calibration routine for this, because, you know, this equipment wasn't originally assembled like this. Okay, so we've got two traces up. That's something, isn't it? Intensity seems okay. So let's plug our signal in now. Oh, got something there on channel 2. Let's get channel 1 on. Something there on channel 1. Okay. So let's go on 10 volts per division, and let's put these traces on top of each other, so we should be able to get an idea if the calibration is okay. So that's not too bad. So we're on 10 volts per division at the moment, channel 1 and channel 2, and we've got 5 volts peak to peak in. So we'd expect that to be about 1 square high, wouldn't we? And it looks a little bit under that at the moment. It's under a square, so maybe there's a little bit of tweaking we need to do. So let's go to 5 volts per division, so that should then occupy 1 full trace, and approximately it does. Yeah, they're fine. 2 volts per division. There should be 2.5 divisions on here now. So let's just line that up on that. Line that one up. Yeah, just over 2.5 divisions, so that's looking good. Let's go to 1 volt. We should have 5 divisions now. Just line that one up. 1, 2, 3, 4, 5. Yep, 5 divisions. So go to 0.5 and we're going to go off screen now. What we'll do is we'll just turn the signal generator down a bit, the level on that. We'll put it on 1 volt per division now. Amplitude 1 volt. So we should have 2 divisions there now, have we? Yeah. 5 divisions we should have now. Have we got that? One, 2, 3, 4, 5. Yeah, about there. 0.1. I think we're going to go off scale, aren't we? Yeah, but it looks right. Let's put it on. Let's go to 0.5 volt now. On the signal generator. Amplitude 0.5 volts. Actually, so let's do 50 millivolts. Amplitude 0.05 volts. So that should be 0.5 division where we are, which, yeah, it probably is. That should be 1 division. Two and a half divisions, which we've got. This one should be. Next one should be 5 divisions. One, 2, 3, 4, 5, which it is, and finally. Okay, so I think out of our 2 scopes, we've got one that now works. Well, appears to work very well. So that's good, isn't it? Quite happy with that. Well, I think we'll time to quit while we're ahead. As always, thanks for watching. That'll do.